Welcome to a short presentation on the Google and Kaggle 5-day Gen AI intensive course that I just completed. The course itself finished about 2 weeks ago, but the capstone project is due soon, and as part of that, you submit a notebook which is to demonstrate your kind of learnings and knowledge you've gained from the intensive course. So I've just shown here roughly the contents. They've created this kind of self-paced learning guide if you want to see kind of what's involved. The foundational models, prompt engineering, vector spaces, vector databases, embeddings, vector stores, generative AI agents, this domain specific LLMs, and this ML ops for generative AI. So at the end, we were looking at doing this capstone competition project. So we're submitting a notebook, myself and my colleague, and the idea of this is to again demonstrate just some of the things that we've learned in the competition. So I'll just show you quickly the competition before we look at the notebook. So the idea is to demonstrate some Gen AI capabilities that we learned in the course, and then there's a scoring system for the notebook. So just the notebook itself is how creative or novel or innovative your particular take on the capstone project is, and kind of how well it's documented. And then there's bonus points for a blog post, which I'm in the process of finalizing, and this will hopefully turn into the YouTube video itself. So the kinds of things that the notebook is looking to demonstrate are listed here, and it's likely that the notebook we have is going to demonstrate in a kind of a small extent the structured output, some document understanding, embeddings, retrieval augmented generation, and vector search, vector store, vector databases. So the idea that we had, given that we had a limited kind of amount of time to work on this and generate ideas, was to use something that we could kind of directly use ourselves in, after working on it for a short period of time. So we were both working on research, and one thing that comes up a lot is you find yourself searching for papers on, for example, arXiv.org, which has a lot of preprints, and you might be looking for this for a number of different reasons, whether it's like references or new ideas or trying to stay up to date with the latest methodology. And so you might be searching often either here or with other tools, Google Search, Google Scholar, to try and find relevant papers to your field, to your methodologies, and to your general interests. So we thought we would write a notebook that uses the arXiv API, and then we combine that with some generative AI to help filter and summarize relevant papers to the user. And now the limitations are kind of that this has to be contained within a Kaggle notebook. It has to be. I'll quickly jump back to the submission here and how it works. Essentially, the notebook has to kind of run without errors. It has to be executed end to end without errors. And generally publicly viewable. So the thing about making it run without errors, it's a little bit tricky planning to work with an API, which the data can change day to day. So there needs to be some kind of fallbacks in place if this is going to hopefully run without errors when it's being evaluated by the Google competition assessors. So we've attached a database of just 5 arXiv papers that we'll try to use in any event of like an error parsing data from arXiv's API, or some other errors that might crop up. And I'll try and show this as I kind of go through some sample output from the notebook. So um, when you can look at this kind of yourself. The notebook should be available by the time you see this video. And generally the use case is to, as I said, be able to kind of filter and summarize papers that are relevant to your interests. And the kind of limitations then we will kind of see as we move along. But the suitability of LLMs, I think it's essentially that LLMs kind of have a good ability to summarize uh, like large text, and to an extent, with limitations, documents. There's the more complex a document gets, the longer it gets, the more likely there will be some kind of hallucinations and errors. But at the same time, if we treat this as a kind of a first step towards kind of automating and let's say a kind of a smart AI augmented search, well then I think this is a good example and a proof of concept, say, of using LLMs to be able to filter results, scientific papers in particular, to kind of save time for researchers. So just to quickly go through the notebook to show what we do. So there's some packages imported. This is the as I said, there was a kind of a fallback data set. This of 5 arXiv papers that we are going to use. So this is just some pre-downloaded metadata in case there's any issues with the arXiv API on the particular data that's running. And then we install the Gemini and ChromaDB for a database to store some output from the LLM. And at the moment, it's using a package called feed parser to parse the arXiv metadata. Although looking further into it while making these blog posts and this screen recording at the moment, there might be other packages, like there might be an arXiv package itself that you could use, so you could streamline this further without having to write any sort of custom query functions. So we import the Google Gen AI, some markdown and display functions, ChromaDB, and TQDM just for any longer for loops that we would like to see a kind of a progress bar on. The retry function is set up for any issues with querying the API and importing the API key itself. So there's some hidden cells here, and that's just a list of arXiv categories and just some code that gathered the test data, the metadata that was in a very long list there at the start, for if we have to fall back to the test the arXiv 5 papers. So we've created just a few kind of functions that are going to help. So this one is just setting up a URL that we can query the arXiv with, and we just check if a particular query returns any results, and if it doesn't, this status indicator is just going to tell us to fall back to the data set that's in the input instead, the 5 papers. So if all goes well, there should be some papers, like we can get like an arXiv reference number, for example. And then what we do is we give we create a description of ourselves. So we're some kind of a researcher, we're interested in some particular fields and areas, and then we give an instruction to the LLM to tell it that it's going to take papers and try to evaluate them for kind of relevance and how to kind of go about that. So what kind of measures they should use. I should look for like a relevant field to the user's description, maybe relative methodology or some keywords that might match between the paper and something that's likely to be in the user's field of research, for example. And then we give it some evaluation steps to do, so to kind of assess the titles and the abstracts that we're going to give it from the search data. And that's where we pass in here the user's description and the title and the abstract. And then what's going to happen is it's going to try and structure those evaluation results into an enum. So it's going to either be relevant or irrelevant, uh, based on the kind of rubric that we've given it. Um, so we just build a function that passes in the user's description, the title, the abstract of a paper, and then an output essentially saying whether or not we think it's going to be relevant or not relevant to the user. So for example here, this is just a sample. It says it technically matches the user's topic of super resolution, and it's a method you're interested in, and then but the particular application is differs from their focus, like their kind of field and so on, and so it gives it a score of 0 instead of 1. So there might be a case that you might give it a score of 1 or a score of 0, but it's just a sample. I feel like a topic like this could go either way. Some other topics might be more clear cut when they have um nothing in common, say, with the user's field or the user's methodology, for example. So, and then how we use this to filter kind of results. So we're going to use a Gemini 2.0 Flash. And what we're going to do then is we're going to just in a loop go through the data, and we're gonna upload that then to to Gemini. But the first thing to do, because again this is expected to run all in one shot, is to kind of have some fallbacks in place. So for example, we want to make sure that if the query fails, we fall back to the arXiv data. If we have some issue getting the PDFs, for example, from the search results, then we want to just again use the fallbacks. If the papers are actually too large, like there's a file size of 50 megabytes, for example, then again we don't want to try and upload that because we'll get an error. And if there's any issue, like all the papers are too large or none of the papers are deemed relevant, again we have some kind of fallback to either use all of the papers that aren't too large, or if none of those are the case, then to just again fall back to the test data. So there's a function to get file size and check if it's small enough to be uploaded. There's a function here which we're going to use to check if we're going to call that a relevance rubric here by uploading the description, the title, and the abstract. And then this is the output of this again is going to be an enum, which we're just going to check if it's equals to 1, which is relevant. So true or false is going to be returned here for whether it's relevant, and it's 1 if it is relevant. And so we also for later we're going to want the metadata that's associated with these papers. So we just store that into a set of dictionaries, and a lot of this is again some kind of fallback. So whenever the status is 1, it's something is working, like the queries and are working. We're able to get the right PDFs. But if anything goes wrong, we're going to accept and set the status to 0, and we're going to fall back to our test data. And then here we try and do the filter. So we have all of the metadata that we built from the requests or the test data. We're going to check that the PDFs are small enough and that they're relevant. And then all of these are again the kind of edge cases that might happen when you try to run this in one shot. So it could be the case that actually none of in this case we've limited it to 5 results, just to keep the notebook from running for too long or to run into any upload limitations with the API. We've filtered we might have filtered out all of the data. For example, none of the recent 5 papers are actually relevant to our user. So if that list is empty, then the filtered data list is empty. Well, then let's fall back to all of the papers. Since none of them are relevant, we might as well use some of them anyway, and just make sure that the PDF files themselves are small enough to be uploaded to Gemini. And then if we're fairly unlucky and all of the PDFs are too large, then we'll just fall back to the test data, because they've been tested to be relatively small, like less than 2 MB. So, and this is just some example of it grabbing some papers. There's a particular paper that's too large, and and then that gets ignored, and then there's only 4 other possible papers, all of which are relevant. So then we decide to just take those 4 papers. So that's the kind of fallbacks in action, for example. And then this is just printing the titles of the papers to have a look at. So um, the then we create an embedding function, because what we want to do is we want to take summaries of the papers and store them in a database for later usage. So the summaries we're going to do, we're just going to say we want some kind of high level summary of the papers that we've downloaded. And we also, for kind of future searchability and usage, it would be nice if it could generate a list of keywords, for example, from the paper. So that's just a function to give this request and the file itself. And then we just do that in a loop. So we, again, just make sure that the papers are small enough. At least while we're kind of testing and things, it's handy to force the database to update, but it might be nice if you want, for example, to have it that only if the paper isn't already added. Like if you're going to run this code multiple times, if the paper is already added, then maybe you don't want to replace existing existing entries, like summaries, for example. Although this is something you can kind of work on a bit more if you're going to take this kind of further. You might have cases where you might want to grab the most recent version of the paper if it exists, and so on, but we're just keeping it simple for the moment. So anyway, so once the papers are summarized, we take that summary and we add it into a ChromaDB database with its metadata, and we use the ID of the paper as an ID, so the kind of archive number. And then just as an example, this is the kind of output that you get of a particular paper. So you get a kind of a summary of the paper, and then we get kind of some keywords and key ideas from the paper. And then we can see that there was 4 entries in the database, and then we can think of doing some sort of retrieval augmented generation. So just again to kind of demonstrate some other things that have come up in the Gen AI course. So what you might want to do, for instance, is maybe you're just as a simple kind of use case why you might be looking at recent papers. Maybe you want to run a journal club in your university or in your research group, and so you'll have a kind of a script that's grabbing the recent papers, trying to keep them somewhat related to maybe your research topic. And so you might give it a list of, and in this case we're just giving it one, but you might say here's our journal club topics, and give it a list of keywords, for example. And then you can do a database query with our summary, which, as we've mentioned, has a bunch of keywords, and then that might return, for example, in this case, super resolution. It just happens to be one of the topics of this paper anyway. So like, and it's part of the keywords as well. So for example, what will happen then is you'll retrieve a particular entry or potentially multiple entries. You could kind of imagine expanding this to have multiple entries and to do multi-document processing. But for the moment, again, limitations to this notebook, we want to keep it simple. We try to minimize some points of failure, because there's potentially a lot of them using the API. But what we do then is we take the retrieved documents, the retrieved summaries, the metadata, and we ask Gemini once again to pretend it's an expert scientist, and that it's going to help us select papers for a journal club. And we're going to again give it the kind of description of ourselves. We're going to give it the paper to work with, and which is the document itself. But we're also going to give it the summary and the keywords. And then what we'd like it to do is to generate kind of a recommendation. Whether it recommends this paper and for a journal club, and can it use some of the keywords, for example, to suggest relevant background topics that would kind of complement the discussion. So, just as an example, again, it says it looks like it's a good fit for the journal club, but it's not directly related to your research area. That's fine. Um, because again, in the fallback data set, there's a chance that the papers don't really align with the provided search topic. So, um, it's okay if we added in kind of an extra point that it doesn't matter that much if the journal club topic doesn't match perfectly. So it still gives its kind of recommendation. So it says it checks whether you're kind of suitable for it, and it gives you some ideas like keywords that would be useful for background reading. It seems to also suggest specific sources sometimes for background reading, which I think is again something you have to take with a pinch of salt. So it could be that these are maybe in the paper itself. It could be hallucinations or something. So it's something you can kind of think about checking, but would have to be kind of checked and fact checked. So, but this is the kind of idea. It's just supposed to something that's going to augment your decision making process for papers. It's going to automate kind of generating suggestions for papers and give you some extra kind of things to think about and make decisions based on it. So again, the kind of limitations then, if we just go back to the start here. So while I think LLMs are particularly suitable for this because they can take documents, large amounts of text, and they can do reasonably good summaries. Um, they seem to be able to, interpret and generate recommendations based on the text in quite a good fashion, and quite like much faster than people would be able to digest like text like this. Uh, Again, the drawbacks are that some of this is going to depend on the kinds of prompts you're using. It's going to depend on the complexity of the papers. It's going to depend a lot on the just the model itself. So, as models improve, maybe this sort of idea improves itself. But there is going to be there is a potential that this will change a lot, like how well it works from model to model. And same with hyperparameters. If you think of like increasing temperature, or it might be the case that you get less factual but more kind of creative suggestions. So there's a lot of considerations essentially that are worth um, exploring and being aware of, like knowing the kind of drawbacks as well as the potential utility of it. So um, yeah, so that's a quick kind of presentation of what the notebook aims to do, and um, and then hopefully everything runs smoothly then on the day that you happen to be viewing this or testing it yourself. Okay, thanks very much. Bye.